Hi everyone, welcome to my channel. This is the first video of logic building series. This series contains multiple modules that help you a lot to build your logic and grow up your career in data structures and algorithm. Basically, today we are going to implement Armstrong number using C++. You can use whether Java, Python, anything else. That's all about your logic. Basically, difference in syntax. Otherwise, logic is same. So basically, what is Armstrong number? First of all, what is Armstrong number? Let's understand this through a example. Suppose we have a digit 153 and we have to check whether this digit is Armstrong or not. So the concept of Armstrong number is basically a digit is Armstrong if in this we have to extract this and find the sum of all. Simple meaning 1 raised to the power count of digit. That means here in 153 count of digit is 3. So 1 raised to the power 3 plus 5 raised to the power 3 plus 3 raised to the power 3. If the sum of these equal to 153, then this is our Armstrong number, otherwise not. Okay, so this is Armstrong number. You can also check whether say 1634 or 371, and that's all. So the logic is very simple. We have to find the sum, check whether a sum is equal to original number or not. Firstly we have to count the number of digits. Okay, let's implement it through a code and check whether our concept is correct or not. So I'm using C++. You can use whether a Java, Python, C, anything else. Has include bits slash stdc++ dot h. Okay, this contain all the library, math, numeric, algorithm, and that's all. So that's why I directly include this using namespace std int main. This is our main function. We will create our own function name. Anything name should be anything. It's on your choice. So we have int arm num, and that's all. We'll declare variable n inside this, and that's all. We'll create our own function. Now we will implement our logic in this function and call this function into main, and after that we will see output is the output correct or not. So first of all we will declare a variable sum. Int s is equal to 0. So s is sum, and int y is equal to n. We will copy the value of n in another variable that name y. So you have to do this due to the contradiction. Okay, now we have to count the digit. We have several methods to count the digit. While n is greater than 0, you have to find the last digit. L is equal to n percentile n modulo 10, basically n modulo 10, and n equal to n divided by 10, and you have to declare a variable c is equal to 0, and here c++, and that's all. This is I'm not going to do this. I have a very simple formula to count the number of digits. Very simple. I'm not using this way because I'm not interested in this. I have a simple formula int log base 10 n plus 1. if you have to check whether it is correct or not. I will run it. Int n, c in n, num n. Okay, and that's all. Oh sorry, control s. Now open the terminal through control shift backtick, and our command is g++ file name. Okay, okay, what happened in term num? Oh, here we required a semicolon and control plus s. Sorry, g++ quest.cpp. Okay, and according to me it's all right. Yeah, now we have a number 153. Check whether, oh, cout c, we forget to print this cout c. Yeah, that's a normal fault. G++ quest.cpp. Yeah, 153. Yeah, count the number of digit, it's 3. Yeah, working properly. So this is a logic to count the number of digit. I will use it. You can use whether c is equal to 0 and count plus plus as you wish. Now let's understand the concept of this. This is basically used to extract the digit. Suppose we have a digit, let's suppose d is equal to 371. 371 we have. Okay, now this 371 goes and stored inside the n, and after that this n, this process goes to while loop, and whenever n is greater than 0 we will perform this compiler will perform this, and that's all. 371 modulo 10, this gives us 1, that is the last digit of the number. After that 371 divided by 10 and gives us 37.1. now this is in integer form, so it gives us 37. After that 37 modulo 10 gives us 7, that is the second last digit of the number. And now 37 divided by 10, 7 divided by 10 gives us 3.7. so we have an integer data type, then it gives us 3, and after that 3 modulo 10, that is 3, and that's all. We extract the digit from the number. So now this is a very simple logic. If you want to if you want a brief description about this, please comment, I will make a video on this. Okay, and also if you want a brief description about the extraction of digit, I will definitely make a video on it. Okay, now we have to basically check whether a number is Armstrong or not. This is a very simple formula. We have declared a variable sum. Now check, we have to find the sum of the digit. Sum plus I will use here power L comma C. This is basically L is the last digit and C is the count of digit. That is, for any number it vary number by number. That means for 153 it is 3, for 1634 it is 4, and that's all. That's the simple logic to find the number of digit. This is very simple formula according to me. And now the main logic is that if why here, because we stores the original number in another duplicate variable that names y to reduce the contradiction. If y is equal to s, we will say simply this is Armstrong number. Yes, in Java we will use system.out.println in C++, cout in Python, print in C, printf, anything else, whatever you want to use, you can. Basically, our main aim is to learn the logic. If we have a logic, then we will do anything. Okay, in else block we will simply print no. Okay, and that's all according to me. Check whether I'm missing semicolon or not. According to me, that's all right. Now control plus s, and guys, we have to remove this because we don't need the number of digit. We simply want to check whether a number is Armstrong or not. Okay, so simply I am going to run this. Control plus s, our command is g++ file name. After that, a tab. Okay, and give a output. Suppose we have a number 371. Yeah, and that's all. 371 is Armstrong number. Check whether a 4-digit number, that is g++ quest.cpp. Okay, right. 4-digit number 1634 is a Armstrong number. Yes, definitely. Check whether for a 1-digit number. Yeah, g++ quest.cpp. We have a tab. Okay, 1. Yes, 1 is definitely a Armstrong number. Check whether for any 2-digit number. Let's see what will be the output. quest.cpp. Okay, I have to run this in a new terminal. Control shift backtick g++ quest.cpp. Okay, a tab. Let's suppose we have a 2-digit number 20. No. And another important point to be remember is that 2-digit number can never be Armstrong number. Okay, I will write it. 2-digit number can never be a Armstrong number. Okay, so that's it for today, guys. I hope this will help you a lot to grow your interest in DSA. Basically, this will help you. This will basically helpful for a beginner who start their career in data structure and algorithm. And please do subscribe and like this video, because your one like motivate me a lot to make this video. And our remember guys, our this series, logic building series, basically contains multiple modules that help you a lot another time, that help you a lot to grow your career, to grow yourself, to build your logic. And that's a lot. Thank you. Thanks for watching.